lamina of side 25 mm is having a side on both HP and VP. The surface of the lamina is inclined at an angle of 60 degree with HP. Draw the top and front views of the lamina. As it says that the surface is inclined at 60 degrees to HP, so obviously we have to start from the horizontal plane. So that means the surface has to be inclined at 0 degrees to HP, and such that one of the side is resting on HP. So we make this side perpendicular to VP. Since it is a odd size, always whether it is corner is resting on HP or the side is resting on HP, always the side has to be perpendicular to VP. So here we can see that side AE is perpendicular to VP. So that is the reason why you are getting a point in the front view. And as we see, all the sides is resting on HP. So obviously it is parallel to HP, and we can see the true shape here. And also when you look from the front view, ABC is near to the observer. So A dash, B dash, C dash is visible, and D and E is away from the observer. So D dash and E dash will be in bracket. So here you can see that the surface is parallel to HP and perpendicular to VP. So that is the reason why you are getting a line in the front view. And as we see from the top view, all the sides are visible. So A to B, B to C, C to D, D to E, and E to A, all the sides are visible. And therefore, we can see here, you're going to get a surface in the horizontal plane. And that is what we have shown. You draw a pentagon with one of the side has to be perpendicular to VP, and you are getting a point in the front view, so that the surface is parallel to HP, and that is the reason why you're getting a true shape here. And also it is perpendicular to VP, so that is the reason why in vertical plane you are getting a line. Then the side is resting on HP surface such that the lamina makes an angle of 60 degree with HP. So here we can see one of the side is resting on HP, so that side is AE, which is perpendicular to VP, is resting on HP. So A dash, A dash. So here A dash is near to the observer and A dash is away from the observer. Therefore, A dash is visible and A dash in bracket. So here the surface is inclined to HP, but still that surface is perpendicular to VP. So that is the reason why you are getting a line here. So, and here you can see that the side is resting on HP such that the entire surface is inclined at an angle of 60 degrees. So we are rewriting the front view position, first position of the front view by rotating at an angle of 60 degrees to HP. And when you look from the top view, we can see the pentagon. Here AB, BC, CD and DE all are in apparent length, and since A dash, E dash is the one which is parallel to HP, so you are getting the true length here. And then he says the pentagon lamina having a side on VP also. The side which is resting on HP is also resting on VP. So we have to rewrite the second position top view by rotating at an angle of 90 degree in a clockwise direction. Then only AE will be on vertical plane. So here you rewrite the second position top view such that the side which is resting on HP is also resting on VP. So you're going to get the pentagon here, and then when you draw the projections in the front view, you will going to get it like this. You can see both A dash and E dash is on HP and AE is on VP. So that is what he has shown here on the expansion. So when you look from the, you can see here, this is a side which is resting not only on HP and it is also on VP. And this entire surface is making an angle of 60 degree with respect to the HP. So when it's projected, you will going to get it like this. And so this is how you will be able to analyze both in 2D and also on 3D. Now we will going to draw the problem in the sketchbook. First we are going to draw the XY line and mark VP and HP as shown with a thin lines. Then draw a line perpendicular to the XY line at any convenient distance from the XY line, and you mark this point as small a and small e. And then with A as center with respect to AE line, by using the protractor, you measure an included angle of 108 degree and then draw an inclined line from A. Then similarly from the point E with respect to EA, you measure an angle of 108 degree and then draw an inclined line from the point E. And then by using the compass, you measure the distance of 25 mm with A as center, cut an arc on the inclined line drawn, and also from E cut an arc on the inclined line drawn, which will be 108 degrees included angle or 72 degree with respect to the exterior angle. So you mark this point as B and D. Then by using the compass, you measure the distance of 25 mm with B as center, draw an arc, and similarly with D as center, cut on the previously drawn arc so that you are going to get this point as C. Then join A to B, B to C, C to D, D to E, and E to A with a dark line. So then we need to write the front view. Draw a vertical projector from A and E to the XY line. Draw a vertical projector from B and D to the XY line, and draw a vertical projector from C to the XY line, so that all these lines are the projector lines, which means that it will have to be a thin line. As you see from the front view, A, B, C is near to the observer, so A dash, B dash, C dash is visible, and D and E is away from the observer, so D dash and E dash is in bracket. Then join A dash to C dash with a dark line. As you see, one of the sides is rested on HP, so they make the side which is perpendicular to VP is AE. You mark it on the XY line by taking the convenient distance from the first position front view. You mark this point here on XY line, and you mark this point as A dash and A dash in bracket. Then by using the protractor with respect to the XY line, you measure an angle of 60 degrees and draw an inclined line. Then by using the compass, you measure the distance from A dash to C dash with A dash as center, cut an arc on that inclined line drawn, and you mark this point as C dash. Similarly, measure the length from A dash to B dash by using the compass with A dash as center, transfer it on the second position front view on the inclined line. Then you mark this point as B dash and D dash in bracket. Then join between A dash to C dash with a dark line. Similarly, draw a vertical projector from A dash and A dash. Draw a horizontal projector from A and E. Both will going to intersect at this point, which is A, and at this point it will going to be E. Similarly, draw a vertical projector from B dash and D dash, and draw a horizontal projector from B and D. Both will going to intersect at this point B and D respectively. Similarly, draw a vertical projector from C dash and draw a horizontal projector from C. Both will going to intersect at these 2 points, and you mark this point as C. Then join A to B, B to C, C to D, D to E, and E to A with a dark line. So as it says that one of the side is resting on HP, the same side is also resting on VP. So you make this EE because the side which is resting on HP is A dash, and that side is now in the top view is perpendicular to VP. You have to make that has to rest on VP. So you reproduce the second position top view by rotating at an angle of 90 degree with respect to the clockwise direction. Then you measure the length from AE, then you transfer it on the XY line here. Similarly, you measure the distance from A to this point, transfer it on from A to this point. And similarly, from this point, you draw a vertical projector perpendicular to the XY line, and then you measure the distance from this point to C. From this point, you cut an arc on this line, you're going to get this point as C. And then you measure the distance from this point to this point, and from here, you cut it on that perpendicular line, you're going to get this point. Similarly, to this inclined line, C to this perpendicular to the XY, you draw a horizontal line from this point, and then by using the compass, you measure the distance from this point to B and also from this point to D, and transfer it from this point to B on this side and also from this point to D on this side. You mark this point as A, B, C, D, and E, then join A to B, B to C, C to D, D to E, and E to A with a dark line. As we see, AE is here itself in the top view, A dash, A dash is also on the front view on XY line, so you mark this point as A dash and A dash. Similarly, draw a vertical projector from B and D to the front view, draw a horizontal projector from B dash and D dash, and you mark this point as B dash and D dash here. Similarly, draw a horizontal projector from C dash and draw a vertical projector from C. Both will going to intersect at this point, and you mark this point as C dash. And then join A dash to B dash, B dash to C dash, C dash to D dash, and D dash to E dash with a dark line. So this is how you will be able to get the solution. As we see that a side is both resting on HP and VP, you can see that AE, which is on XY line in the top view, and also A dash is on XY line in the front view. So it is a case wherein side is resting on both HP and VP. And as we see in here, the side is resting on HP and it is also inclined, the surface is inclined at 60 degrees to HP, and it is a pentagonal lamina of 25 mm side. So this is how you will be able to solve the problem in the sketchbook.